So before I begin my presentation, so I have one question. Do anyone listen my presentation of this content before? Please raise your hand. Okay, fine. The majority of our audience don't know the content, so excellent. So it doesn't matter if you have already listened that. I will provide you some new information. So my topic is on generative agents in recommendation. First of all, I will briefly introduce myself. My name is Zhang, the research fellow in NUS, National University of Singapore. First thing is, actually, a large language model exhibits characteristics of artificial general intelligence, which has cognitive abilities similar to that of human. So in other words, AI can now perform most functions that humans are capable of doing, right? But this is totally not enough for us. Nowadays, we only achieve linguistic intelligence, but towards artificial general intelligence, we want something more, like we want our model could observe, remember, do reasoning, use tools, do action, or even learn from others, do self-reflection, and do autonomous nature. It has autonomous nature. So we think we need some new things to achieve this kind of artificial general intelligence. Right now, there is a potential solution that is trying to build agents. So what is agents? Agents, first, it needs to communicate with environment. So it needs to observe things. Instead of just text, we want the agent has multimodal perception, which means we can also have some input like speech, code, data, or structured data, etc. And also, we want our agent can action more than just generate text. We want our agent could do embodied action or learn tools, using tools, making tools. Tools means we can call external APIs for actual information that is missing from the model weights, the large language model's weights. This kind of weights is pre-learned and often hard to change after pre-training. So we want to use this API to access more capabilities. After that, we want to build our agent. The agent may have many modules, like memory modules or decision-making modules. For memory modules, which means we want this agent can store sequence of agents' past observations, thoughts, or actions. This is something like condition. I mean, for each different agent, it will have different past observations and thoughts. And these differences will affect their action in the future, right? So the second module is decision-making process, which consists planning, reasoning, etc. Planning means we want sub-goal and decompose it, a quite complex text, into subset, right? Which is much easier for agent to finish the task. And for reasoning, we want our agent capable of doing self-criticism and self-reflection, which means they can learn from past observations, past actions, past feedbacks, and learn from mistakes and refine their thinkings, thoughts, or actions. So based on this environments and construction, we further have collaboration, which means we have multiple agents. We don't want only single agent. We want multiple agents to complex the task. And sometimes we have also human in the loop. So basically, this is an overview of agent. but it seems like nothing related to our topic. Yes, so how could we do like agents with recommender systems? First thing is, actually large language model-based agents may reshape the research paradigm of recommender systems, because first, we can use this recommender agent to simulate users or simulate recommender itself. For agents simulate users, we have only two questions to answer. The first question is, can large language model agent generate faithful user behavior? Right, this is very important. If not faithful, it means nothing. Right? The second one is, well, if the agent could truly generate faithful user behavior, is that possible that we can use this generated behaviors to further benefit our recommender? Right? This is the second question. So we have some experiments here. First, to answer a question like, can large language model agent generate faithful user behavior, we construct 1,000 large language model empowered generative agents, initialized with real data, which means for each agent, it has the real users, right? And all these agents will also be augmented by GPT. After that, we have user profiles, something like activities, conformities, diversities about the users. And we also have item profile. The item profile consists of something like statistical information in data set and generated summary. Based on all of this, our agent also has two modules. The first module is memory module, and the second one is action module. These two modules enable our agents to recall past interests and plan future actions. The future actions may have something like watch, rate, evaluate, to interview, and so on. And also, we have the recommendation environment. Agent for Rank also conduct personalized recommendations in a page-by-page manner, right? In most cases, recent days, we have page-by-page recommendations. And we also have some pre-implement recommendation algorithms, such as MF, JSON, multi-VAE, and so on. So based on this construction, we do some experiments. The first experiment is we find out that agents are capable of preserving the user's social traits and preference, such as rating and diversity. This is a group level behavior, user behavior, right? The second one is incorporating the agent's rating as augmented data. We can somehow enhance the recommender's performance, but not that much. The third thing is we find out that we want to do some basic understanding about our agent and recommender systems. So we're trying to learn the causal graph of recommendation. This cannot do before, right? But because we have this platform, we can generate data and do this causal discovery. We use Leheng to analyze the results, and we find out this, you can find very interesting. The two things influence the movie rating is movie quality and movie popularity. And you can find popularity bias here. Movie quality will influence the movie popularity. The movie popularity will further influence exposure rate. Here, the exposure rate is a recommender's exposure rate. And this exposure rate will further influence the view number. So basically, this is a very clear population bias here. Right? Based on all of this, we find out that we can offer a simulation platform to test and fine-tune recommender model. It tells that, well, large language model-based AI agents are able to generate faithful behaviors. But this is not enough at all for us. We want that we can use this kind of generated behavior to further benefit our recommender. So we do an updated version. We use fine-tuned GPT 3.5. And we conduct more extensive experiments on 3 data sets from different domains like movie, book, game. We can find out that very interesting. Yuxin can closely simulate actual select number and successfully simulates over 90% of real user preferences in all data sets. You can find out here, like for Amazon book, the ground truth positive is around 6 to 7. And here for Yuxin, we select around 6. Right? But for others, we may have like more than 10. Right? So it is very accurate select numbers. The second thing is Yuxin consistently and significantly strengthening the backbone models for recommendation. We can find out that the improvements is around 5 to 25 or 30%. The third thing is we find out that recommenders augmented with Yuxin's simulated interactions perform comparable or even surpass those augmented with an equal number of ground truth interactions. Like here, this one is augmented with ground truth, and this one is augmented with Yuxin's generated interactions. Very impressive. It means sometimes, although it may not be true from our test perspective, but it is truly benefit for recommender. We also conduct a user study here. Like in addition to a sample of 1,000 users from the Steam dataset, we engage 20 real-life volunteers and utilize their actual Steam gameplay histories to construct 20 agent profile. We find out that it truly boosts the performance. Well, this shall be the end of my presentations, but I promise I want to provide some new insights. So I will briefly introduce 2 things, our recent findings. The first one is we find out actually large language models encode collaborative signals in recommendation to some extent, which means we use the text embedding of item. And we find out that we just using a linear mapping, we can achieve a very, very good performance, even better than LLM rack, like Yuxin and some yes. And we find the embedding we use is very important. The second thing.
Can you wrap it up? Can you wrap it up? It's 1 more minute.
Yes. The second one is we trying to use direct preference optimizations to improve the performance of large language model-based recommender. And we find out that it can boost the performance of Lara. Yes, that's all our findings.
Thank you. Thank you, Anne.
Yes, any question?